Good morning, children. In the last class, we learned about reactivity of metals with water, with air, and with acids. I'm repeating it. Reaction of metal with water. You are given three different metals, sodium, magnesium, and copper. What will happen if you put the sodium, magnesium, and copper in cold water and hot water? Okay, that is the experiment we have done in the last class. You can see that if sodium is put in cold water, it reacts vigorously. So obviously if you put it in hot water, then also it will react vigorously. Okay. Then magnesium, it reacts slowly in cold water. Okay. But it reacts vigorously, faster, not vigorous, but faster in hot water. So you can see that in cold water it didn't react. But in hot water, if you put this magnesium, you can see that it reacts faster. If you put copper in cold water, there is no reaction at all. If you put this copper in hot water, then also it will not react. So this we have seen in the last class. So what are the conclusions from this experiment? The rate of reactions of metals with water is not the same. Sodium reacts vigorously with cold and hot water. Metals react with water to form hydrogen gas. Very important, children. Metals, they react with the water to form hydrogen gas. Here, the equation of sodium reacting with water is given here. You have to study this equation. 2Na plus 2H2O gives 2NaOH plus H2. You can see hydrogen gas is liberated here. Now, you are asked to write decreasing order of their reactivity. Sodium, magnesium, and copper are given, and what is their decreasing order of reactivity? You can see that the most reactive metal here is sodium. So sodium is greater than magnesium, is greater than copper. Right? This is the decreasing order from top to bottom. That is the decreasing order. Okay. Now you have to write these questions in your notebook and also the answers. Which gas is produced when magnesium reacts with hot water? See, when a metal reacts with water, you know which gas will be produced. That you have to write. You have to find out the answer and write. And you have to write its balanced chemical equation. Try to find out the reaction between magnesium and water. Here, sodium and water is given. You try to find the reaction between magnesium and water. Magnesium and water, and you know the products. Try to write that equation. Okay. Then, which metal does not react with cold water as well as hot water? Which is that metal that does not react with cold water and hot water? It is, yes, copper. So that also you have to write. Next, we learned about reactions of metals with air. First, we learned reaction of metals with water. Now, we are going to learn reactions of metals with air. You can see that the freshly cut surface of metals will have a shiny appearance. This property is known as metallic luster, that you have studied in 8th standard itself. The freshly cut part of metal will be shiny, and that property of metals is called metallic luster. Now you are given an experiment. Cut a piece of sodium using a knife. Observe the freshly cut portion. After some time, the shining sodium fades. If you cut a sodium using a knife, you can see that the newly formed surface, when you cut, a new surface is formed. No, that surface will be shining. But after a few minutes, after some time, what will happen to that shining appearance? It will fade. So what is actually happening here? This sodium fades because of the conversion of sodium into its compounds by reacting with oxygen, moisture, and carbon dioxide in the atmosphere. You know that in the atmosphere you can see oxygen, moisture, and carbon dioxide. So when you expose this sodium, what happens? It will react with this oxygen, water, and carbon dioxide in the atmosphere, and the reactions are given below. Sodium, it was sodium earlier. The sodium reacts with oxygen to form 2Na2O. This Na2O reacts with the moisture, that is water, in the atmosphere to form 2NaOH, and 2NaOH plus CO2 gives Na2CO3 plus H2O. So these reactions also you need to study. Same way, if you cut a magnesium ribbon, then also you can see that that metallic luster. That part will be shining. But when you expose it for some days, what will happen to it? Yes, its luster will go away. It diminishes. It can be seen that the luster of aluminium vessels diminishes as time passes. If you keep magnesium ribbon for some days, its luster will lose. Same case, you can see that aluminium vessels that are being used in your houses, in your kitchens, its luster will diminishes as time pass by. And the reaction is 4Al aluminium plus 3O2 gives 2Al2O3. That is, as aluminium reacts with oxygen to form aluminium oxide. In the case of copper vessels, it takes months for the loss of its luster. See, copper, it does not lose its luster that easily. It will take months. Okay, but it loses its luster by the formation of verdigris. Verdigris. In Malayalam, you call it klav. Okay, verdigris. So now, shining gold does not fade because it does not react with oxygen moisture in the atmosphere. But you can see the same aluminium, copper. Gold is also a metal like this. But what is its speciality? It's shining, will not fade. If it fades, nobody will buy. No, it will not be that costly. So shining of gold does not fade because it does not react with oxygen, moisture in the atmosphere. So even if you expose this gold to the atmospheric air, nothing is going to happen. Its shining will not go because it will not react with this oxygen and moisture in the atmosphere. So you understood that metal reacts with air at different rates, right? Sodium, only in few minutes it lost its luster, whereas in magnesium, it required some days. In aluminum, it required some months. In copper, it required even more months. So you can see that the reactivity rate with air is different for different metals, and you can see that the least reactive metal here is gold. So if you are asked to write the decreasing order of their reactivity with air, again you can write sodium is greater than magnesium, greater than aluminum, greater than copper, greater than gold. Okay, this is the decreasing order of reactivity with air. Now reaction of metals with acids. In this, you have to do this experiment. Take 5 test tubes having same quantity of dilute HCl. You are asked to take 5 dilute HCl in this 5 test tubes. Take pieces of iron, magnesium, copper, lead and zinc and put it in this test tubes containing dilute HCl. And what are the reactions that you can see? It is very clearly visible from this picture itself that the most reactive one is magnesium. You can see so many bubbles here, right? The next is zinc, the next is magnesium and lead, and then the least one is copper. So metal reacts with dilute HCl to form hydrogen. These bubbles are actually hydrogen gases, hydrogen bubbles. Okay, the rate of reaction of metal with the acid is not the same. From this experiment, you can see that not all the metals reacted at the same rate. Some are highly reactive, whereas some are low reactive. Okay, so metals differ in their reactivity. And if you are asked to arrange the above metals in the decreasing order, again, what will you write? Magnesium greater than zinc, greater than iron, greater than lead, greater than copper. Okay, magnesium greater than zinc, greater than iron, greater than lead, greater than copper. So now you have to find answer to this thing. Why is sodium kept immersed in kerosene? This is a question. This sodium is not kept in air, it is kept in kerosene. Why? Because you already understood if it is exposed to air, what will happen? It will react. Okay, it will react suddenly with atmospheric air and moisture, and new compounds are formed. That you have studied. The equation also you studied. No, this is the equation of reaction of sodium with air. So that is the answer for this. Now we do not keep our sour food in aluminium vessels. Why? Why sour food is not kept in aluminium vessels? Because it will react with aluminium. That's the reason why it's not kept in aluminium vessels. Okay. Now reactivity series, that also we have learned. The series obtained by arranging some of the metals in the decreasing order of the reactivity is known as reactivity series. That you have to write what is reactivity series. The series obtained by arranging some of the metals in the decreasing order of their reactivity. But decreasing order of reactivity means the most reactive metal will come at the top. Okay, and the reactivity decreases as we go down. This is the decreasing order of reactivity, and the series is called reactivity series. Hydrogen is also included in the series. Hydrogen, it is not a metal, then why we are including this hydrogen? It is for the sake of comparison of reactivity. So we are comparing the reactivity of these metals with respect to this hydrogen. That is why hydrogen is included. So those metals that you can see above this hydrogen, they react with the dilute HCl and displaces this hydrogen. So if you put these metals in dilute hydrochloric acid, we can see that this hydrogen will be displaced by the metal. Instead of HCl, that metallic chloride will form. Okay, so this hydrogen will be displaced. But in the case of those metals that are below hydrogen, they do not displace hydrogen from dilute HCl. What does that mean? It do not react. Okay. Now a new topic, reactivity series and displacement reaction. What is reactivity series and displacement reaction? Prepare some copper sulfate solution in a beaker. Okay, now you are taking two beakers. In one beaker, you are putting some copper sulfate solution. So what is taken in beaker 1? Copper sulfate solution is in your beaker 1. And in beaker 2, take another beaker and add some zinc sulfate solution to it, ZnSO4 solution. So you have two beakers. In one beaker it is copper sulfate solution, in the other beaker it is zinc sulfate solution. Next, what you have to do, dip a zinc plate in the first beaker, and second beaker dip a copper plate. In first plate you are dipping a zinc plate, and in the second beaker you are dipping a copper plate. I'll tell you. So what you have two beakers. Beaker 1, this is beaker 1, and this is beaker 2. Two beakers are there. In the first beaker you have copper sulfate solution, that is CuSO4 solution, copper sulfate solution. In the second beaker you have zinc sulfate solution. So zinc sulfate solution is taken in the second test tube. Now what you have to do, you have to dip a zinc plate in copper sulfate solution. Copper sulfate solution like a zinc plate mukkunnu, and in the zinc sulfate solution you are dipping a copper plate. What will happen? That is what we have to observe. Observation, color of zinc plate. Before experiment, its color is ash color. You can see ash color before the experiment, and after experiment, you can see the color of copper. Zinc plate in the mele, copper in the color. You can see color of copper in the zinc plate. Okay, so what you have done, when you dipped this zinc plate in copper sulfate solution, before the experiment that zinc plate was ash in color, but after the experiment you can see the color of copper in it. In the same way, if you look at the color of the solution, you can see that the color fades. Earlier copper sulfate solution was blue in color. Your copper sulfate solution, it's blue in color. So after this experiment, if you see this copper sulfate solution, if you see that solution, you can see that its color has faded. Color മങ്ങിയതായിട്ട് കാണാം. നേരത്തെ blue solution ആയിരുന്നു, copper sulfate blue solution ആണ്. But after the experiment, something happened. Okay, what happened? I will explain later. So something happened and its color got faded. Okay, so and in the beaker 2, what we have done? We have taken zinc sulfate solution and dipped copper plate. There is no change, or there is no reaction taking place. You can see that nothing has happened. No color change, nothing has happened in beaker 2. So what are the things that you can conclude from this experiment? Again, remember this experiment. You have taken two beakers. One contained copper sulfate solution and the other contained zinc sulfate solution. Now what you are doing? You are dipping zinc rod in copper sulfate solution and copper rod in zinc sulfate solution. So in your first beaker, the observation that you found is, earlier the zinc rod was ash in color. Now its color has changed to the color of copper. When you see this copper sulfate solution, earlier it was blue color. Now that solution's color has faded. Okay, that is the observation from beaker 1. And in beaker 2, we can see that nothing has happened. No change. There is no reaction. Okay, no change is observed. Okay, from this, what are the things that you can conclude is, the blue color, listen children, the blue color of copper sulfate solution is due to the presence of Cu2 plus ions. I tell you, in copper sulfate solution, the blue color in karanam Cu2 plus ions are. Okay, when the zinc plate or zinc rod is dipped in that solution, the Cu2 plus ions in the solution get deposited at the zinc plate. So copper sulfate solution copper evide vannu deposit ayi zinc plate. That is, copper sulfate solution il ninnum copper ne zinc endu cheedu displace cheedu. Okay, zinc removed this copper from this copper sulfate. Okay, copper sulfate in the zinc copper ne remove ചെയ്തിട്ട് copper ഇരുന്ന സ്ഥലത്ത് zinc വന്നിരുന്നു. Displace ചെയ്യുക. Displace means you remove that. Okay, but here zinc is capable of, or zinc is so strong that it can displace copper from copper sulfate solution. Okay, അപ്പോൾ കോപ്പറിനെ ഡിസ്പ്ലേസ് ചെയ്തപ്പോൾ കോപ്പർ എന്ത് ചെയ്തു? കോപ്പർ പോയിട്ട് സിങ്ക് റൂട്ടിൽ ഒന്ന് അറ്റാച്ച് ആയി. Okay. Now, what happened? So the reaction is given here. Zinc. This zinc is the rod that you dip. Zinc rod is dip. Zinc plus CuSO4. CuSO4, see it is written Cu2 plus SO4 2 minus. Cu2 plus SO4 2 minus. For 9th standard you have already studied, no? Sodium chloride form ചെയ്യുന്നത് എങ്ങനെയാണ്? NaCl form ചെയ്യുന്നത്. Na will donate 1 electron and chlorine will receive that 1 electron. So chlorine will get -1 charge and sodium will get +1 charge എന്നൊക്കെ നമ്മൾ പഠിച്ചിട്ടുണ്ട് അല്ലേ? അപ്പോൾ in a reaction, in the formation of sodium chloride, you can see that sodium it attains +1 positive charge by donating 1 electron, and chlorine it gets -1 charge by receiving electrons. Why it is giving and why it is receiving? Why sodium is giving? Sodium's atomic number is 11. Its electronic configuration is 2,8,1, 281. And you know that in order to become stable, the number of electrons that should be in the valence shell should be, or last shell should be 8. So here in case of sodium, what will it do? In order to make the last shell electron number 8, either it has to receive 7 electron or lose this 1 electron. So what is easy for sodium? Sodium will lose that 1 electron in the outermost shell. So this electron poi kazhinjal, the configuration will be 2,8. Sodium configuration 2,8 ആവും. Electron പോകുന്നത് കൊണ്ട് തന്നെ it will receive 1 positive charge. And what is the electronic configuration of chlorine? Chlorine atomic number is 7 and its electronic configuration is 2,8,7. 2, 8, 7. അപ്പോൾ ഇതിന് അവസാനത്തെ ഷെല്ലിൽ 8 ഇലക്ട്രോൺ ആവണമെങ്കിൽ, ദാറ്റ് ഈസ് ഒക്ടേറ്റ് ഫോം ചെയ്യണമെങ്കിൽ what it has to do, it has to receive 1 electron. Either it has to lose 7 electrons or receive 1 electron. ഒന്നല്ലെങ്കിൽ 7 ഇലക്ട്രോൺ കൊടുക്കണം അല്ലെങ്കിൽ 1 ഇലക്ട്രോൺ വാങ്ങണം. So what will this chlorine do? ഇലക്ട്രോൺ വാങ്ങുന്നതാണ് എളുപ്പം അല്ലേ? So this will receive 1 electron from this sodium. Sodium കൊടുക്കുന്ന ഇലക്ട്രോൺ വാങ്ങുന്നത് ആരാണ്? ക്ലോറിൻ ആണ്. അപ്പോൾ ക്ലോറിന്റെ ഇലക്ട്രോണിക് കോൺഫിഗറേഷൻ it will become 2,8,8. It became stable. ഇങ്ങനെ രണ്ടുപേരും തമ്മിൽ ഒരു കൊടുക്കൽ വാങ്ങൽ നടന്നു. So a bond is formed, and that type of bond is ionic bond that we have studied all of these things in 9th standard. I'm just reminding because many of you might have forgotten. That's why. Okay. So sodium chloride is formed like this. Sodium donated 1 electron. It got +1 charge, and chlorine received 1 electron. It got -1 charge, and thus sodium chloride is formed. In the same case here in copper sulfate solution, you can see that this, in order to form this compound, copper donates 2 electrons and sulfate ions receives that 2 electrons. So here copper gets 2 positive charge and sulfate ion SO4 2 minus charge. Okay, just like sodium chloride Na plus Cl minus, like that this copper metal, it gives 2 electrons to SO4, and as it is receiving that 2 electrons, it will get 2 minus charge. Okay, simply remember that. For copper, how many electrons copper will give? 2 electrons. That's the thing that you should remember. Okay, that's it. So now zinc is dipped in copper sulfate solution, that is CuSO4 solution. You can see that Cu has given 2 electrons to SO4. Okay. Then what happens if you dip it? This copper from this copper solution will be displaced by zinc. Zinc ഈ കോപ്പറിനെ ഇവിടെ നിന്ന് മാറ്റും. അപ്പോൾ കോപ്പർ എന്ത് ചെയ്യും? കോപ്പർ കൊടുത്ത 2 ഇലക്ട്രോൺ അല്ലേ കൊടുത്തിരിക്കുന്നത്? Copper has given 2 electrons in order to form this copper sulfate solution. അപ്പോൾ zinc പറയും നീ കൊടുത്ത 2 ഇലക്ട്രോൺ ഒന്നും SO4 വേണ്ട, SO4 വേണ്ട 2 ഇലക്ട്രോൺ ഞാൻ കൊടുക്കാം. I will give because I am more reactive, I am more strong അല്ലേ? ഞാൻ കുറച്ചും കൂടി ശക്തിയുള്ള ആളാണ്, അപ്പം ഞാൻ കൊടുത്തോളാം എന്ന് പറഞ്ഞിട്ട് ഈ കോപ്പറിനെ ഇവിടെ നിന്ന് പറയും, കോപ്പർ നീ കൊടുത്ത 2 ഇലക്ട്രോൺ നീ തിരിച്ചെടുത്തോ, എനിക്ക് sulfate ion electron ഞാൻ കൊടുക്കാന്ന് പറയും. So sulfate, zinc sulfate ion is, zinc sulfate solution is formed, and this copper, earlier it was copper 2+ അല്ലേ? Cu 2+ ion ആയിരുന്നു. എങ്ങനെ 2+ കിട്ടിയത്? By donating 2 electrons to sulfate ion, but now it got back its ion electron. So Cu 2+ 2 ഇലക്ട്രോൺ തിരിച്ചു വാങ്ങിച്ചു. 2 ഇലക്ട്രോൺ തിരിച്ചു വാങ്ങിച്ചപ്പോൾ Cu ആയിട്ട് മാറി അല്ലേ? 2+ + 2 ഇലക്ട്രോൺസ് പറയുമ്പോൾ -2 ചാർജും കൂടെ ഇനി കിട്ടിയപ്പോൾ its charge became 0. That is copper, Cu, copper atom ആയിട്ട് മാറി, copper atom ആയിട്ട് മാറി. Earlier it was copper ion, Cu2 plus ion by donating 2 electrons. But what happened in this reaction? Zinc is more reactive. So zinc displaced copper from copper sulfate solution, and that copper got the 2 electrons and it became copper atom, and the solution became zinc sulfate solution. Okay, അങ്ങനെ സൊല്യൂഷൻ സിങ്ക് സൾഫേറ്റ് ആയതുകൊണ്ടാണ് അതിന്റെ ബ്ലൂ കളർ ഫെയ്ഡ് ആയത്. കാരണം ബ്ലൂ കളറിന് കാരണം അത് കോപ്പർ സൾഫേറ്റ് ആ സൊല്യൂഷനിൽ കോപ്പർ ഉള്ളതുകൊണ്ടാണ് അത് എന്ത് കളർ ആയിട്ടുണ്ടായിരുന്നത്, ബ്ലൂ കളർ. ബട്ട് വെൻ ഇറ്റ് ഇസ് റിമൂവ്ഡ്, നൗ സിങ്ക് സൾഫേറ്റ് ഇസ് there, no, so that color faded. Okay, so remember, zinc is at the top of the reactivity series than copper because zinc has higher reactivity than copper. Noku, zinc is placed here and copper is here, so which is more reactive? Zinc is more reactive. അപ്പോൾ സിങ്കിന് ആരെ ഡിസ്പ്ലേസ് ചെയ്യാൻ കഴിയും? കോപ്പറിനെ ഡിസ്പ്ലേസ് ചെയ്യാൻ കഴിയും because it is more reactive. Okay, but can zinc displace aluminium? സിങ്കിനെ അലൂമിനിയത്തിനെ ഡിസ്പ്ലേസ് ചെയ്യാൻ പറ്റും, സിങ്കിനെ അലൂമിനിയത്തിനെ ഡിസ്പ്ലേസ് ചെയ്യാൻ പറ്റും? No, it will not, അല്ലേ? അപ്പോൾ റിയാക്ടിവിറ്റി സീരീസ് എന്തിനാ പഠിക്കുന്നതെന്ന് വെച്ചാൽ then only you should understand which metal can displace the other metal from their solutions. Okay, but this series you have to study that also in order. ആ ഓർഡറിൽ തന്നെ നിങ്ങൾ പഠിച്ചു വെക്കണം. Then only you will understand which metal can displace which metal. Okay, here zinc can displace copper because zinc is more reactive than copper. That is what has happened here. Here, when you insert zinc rod in copper sulfate solution, zinc has displaced this copper because zinc is more reactive. But in the case of beaker 2, zinc sulfate solution is there and you have dipped copper rod. Can this copper displace zinc sulfate in the copper zinc in displace ചെയ്യാൻ പറ്റുമോ? ഇല്ല, കാരണം ഇറ്റ് ഇസ് ലെസ് റിയാക്റ്റീവ് ദാൻ സിങ്ക്. സിങ്കിന്റെക്കാട്ടും ശക്തി കുറവാണ്, റിയാക്ടിവിറ്റി കുറവാണ്. അപ്പോൾ സിങ്കിനെ അതിന്റെ സൊല്യൂഷനിൽ നിന്നും കോപ്പറിനെ ഡിസ്പ്ലേസ് ചെയ്യാനായിട്ട് കഴിയില്ല. ദാറ്റ് ഈസ് വൈ ദർ ഇസ് നോ റിയാക്ഷൻ ഇൻ ദി ബീക്കർ 2. സോ മെറ്റൽസ് ഹാവിംഗ് ഹൈ റിയാക്ടിവിറ്റി displace the metals having less reactivity from their salt solution. Such chemical reactions are known as displacement reactions. So these reactions are known as displacement reactions. Here it is being displaced. So metals having high reactivity displace the metals having less reactivity from their salt solutions. So from their salt solution, copper sulfate solution is their salt solution. Copper sulfate solution il ninnum കോപ്പറിനെ സിങ്കിനെ ഡിസ്പ്ലേസ് ചെയ്യാൻ പറ്റി കാരണം ഇറ്റ് ഇസ് ഹൈലി റിയാക്റ്റീവ്. വെൻ കമ്പയർഡ് ടു കോപ്പർ ഇറ്റ് ഇസ് മോർ റിയാക്റ്റീവ്. ഓക്കെ, സോ ഇറ്റ് ഡിസ്പ്ലേസ്. ബട്ട് ഇൻ ദ കേസ് ഓഫ് beaker 2, you can see that this copper is less reactive than zinc. So copper is incapable of removing or displacing zinc from zinc sulfate solution. Okay, now this is the work that you have to do in your textbook notebook. Okay, observe the picture and answer the following. You are given 2 beakers, one contain copper sulfate solution, zinc rod is dipped, copper sulfate solution, silver rod is dipped. Ag means silver ആണ്, Ag silver. Okay, now in which test tube does the displacement reaction occur? ഇതിൽ ഏതിലാണ് ഡിസ്പ്ലേസ്മെന്റ് റിയാക്ഷൻ നടക്കുക എന്നാണ് ഇപ്പോൾ ചോദിച്ചിരിക്കുന്നത്. വെരി സിമ്പിൾ ക്വസ്റ്റ്യൻ. നോ, ഇവിടത്തെ രണ്ട് മെറ്റൽസ് പറഞ്ഞ ഒന്ന് സിങ്ക് ആൻഡ് കോപ്പർ. ഓക്കെ, ഇപ്പൊ സിങ്ക് കോപ്പറിനെക്കാളും റിയാക്ടിവിറ്റി കൂടുതലാണെങ്കിൽ സിങ്ക് വിൽ ഡിസ്പ്ലേസ് ദിസ്, അല്ലെങ്കിൽ it cannot. But you know that it is more reactive, so this will get displaced. Copper will be displaced from copper sulfate solution. But in the case of silver, see, silver and copper sulfate solution, can silver displace copper from copper sulfate solution? It can displace only if this is more reactive than copper. But is it so? Silver കോപ്പറിനെക്കാട്ടും റിയാക്ടിവിറ്റി കൂടുതലാണ്? അല്ല, ഇറ്റ്സ് ലെസ് റിയാക്റ്റീവ് ദാൻ കോപ്പർ. കോപ്പറിന്റെ താഴെയാണ് സിൽവർ വരുന്നത്. സോ നത്തിങ് വിൽ ഹാപ്പൻ ടു ദി ബീക്കർ 2. Understood? And you have to write the chemical equations. Chemical equations, how will you write? Zn plus USO4 gives ZnSO4 plus Cu. Right? This equation, Zn plus CuSO4 gives ZnSO4 plus Cu. Understood? So this is the chemical equation. So this also you have to write. Draw this beaker, write these questions and write the answers. Okay. Now, oxidation is the process of, what is oxidation and what is reaction? That is what I am going to tell you now. Oxidation is the process of loss of electrons and reduction is the process of gain of electrons. Remember, oxidation, what is oxidation? It is the process of loss of electrons. Oxidation. So you should study this code. Oil rig ennu padikkuka. Oil rig. What is this oil rig? Oxidation is loss of electrons and reduction is gain of electrons. Oxidation law is loss of electrons, reduction is gain of electrons. So oxidation എന്ന് പറഞ്ഞാൽ എന്താണ്? ഇലക്ട്രോൺ കൊടുക്കുകയാണ്, ഇലക്ട്രോൺ നഷ്ടപ്പെടുകയാണെങ്കിൽ you will call it oxidation, and if you receive electron or if you gain electron, it is called reduction. When zinc rod is dipped in copper sulfate solution, this is the chemical equation, no? Zinc displaces copper and forms zinc sulfate solution, and copper is removed. Zn plus CuSO4 gives ZnSO4 plus Cu. Rewrite this equation showing the nature of ions. ഇതിനകത്ത് തന്നെ നമ്മൾ ഇതിന് ഇപ്പോൾ ഓക്സിഡേഷൻ സ്റ്റേറ്റ്സ് വെച്ചിട്ട് നമ്മൾ എഴുതുകയാണെങ്കിൽ സിങ്ക് ഏർലിയർ ഇറ്റ്സ് ചാർജ് സീറോ അല്ലെ. സിങ്ക് പറയുന്ന ഒരു സാധാരണ മെറ്റൽ ഇറ്റ് ചാർജ്ലെസ് ആണ് അല്ലെ, സീറോ ആണ്. ബട്ട് അയോൺ സൊല്യൂഷനിൽ എങ്ങനെയാണ് അത് അയോണിക് ഫോമിലാണ് ഉണ്ടാവുക അല്ലെ. കോപ്പർ 2+ ഇലക്ട്രോൺസ് ഡൊണേറ്റ് ചെയ്തു, ദാറ്റ് ഇസ് റിസീവ്ഡ് ബൈ സൾഫേറ്റ് അയോൺ 2-. So 2+2-, a bond is formed, CuSO4 is formed. No? So Zn0 plus Cu2 plus SO4 2- gives, what happens? This copper is removed, that is copper got back its 2 electrons. So now what happens? Zn becomes Zn0 becomes Zn2 plus SO4 2-. SO4ന് 2 ഇലക്ട്രോൺ ആരാണ് കൊടുക്കുന്നത്, അല്ലെങ്കിൽ ആരാണ് എങ്ങനെയാണ് ബോണ്ട് ഫോം ചെയ്യുന്നത്? ബൈ ഗിവിംഗ് 2 electrons by this Zn. Instead of copper, zinc has displaced this copper, and copper got back its 2 electrons and became Cu0 അല്ലേ. ആദ്യം 2+ ചാർജ് ആയിരുന്നു, അപ്പൊ 2 ഇലക്ട്രോൺ കിട്ടി എന്ന് പറയുമ്പോൾ ഇലക്ട്രോണിന്റെ ചാർജ് എന്താണ്? ഇറ്റ് വാസ് 2+, now it got 2- അല്ലേ. 2 ഇലക്ട്രോൺ തിരിച്ചു കിട്ടി വരുമ്പോൾ +2 + -2 എത്രയാണ്? 0 ആണ് അല്ലേ. ദാറ്റ് ഇസ് 0. So that is now copper Cu0. Understood? Here earlier it was zinc. Zinc's oxidation number was 0, but here Cu2 plus is displaced by copper, and zinc got 2 positive charge, and copper, its charge became 0. Understood, children? This is very important. Here, what is oxidation? I told you the process of loss of electrons. Here, which metal lost its electron? സിങ്ക് ലോസ്റ്റ് ഇറ്റ്സ് ഇലക്ട്രോൺ. സിങ്കിന് നേരത്തെ 0 ആയിരുന്നു, സിങ്ക് 2 ഇലക്ട്രോൺ കൊടുത്ത് 2+ ചാർജ് ആയിട്ട് മാറി. സോ ബിഫോർ റിയാക്ഷൻ സിങ്ക് വാസ് 0, നൗ ഇറ്റ് ഗോട്ട് 2 പോസിറ്റീവ് ചാർജ്, ദാറ്റ് മീൻസ് ഇറ്റ് ലോസ്റ്റ് ഇറ്റ്സ് ഇലക്ട്രോൺ. സോ ഓക്സിഡൈസ് ആയ ആറ്റം, ഓക്സിഡേഷൻ മീൻസ് പ്രോസസ് ഓഫ് ലോസ് ഓഫ് ഇലക്ട്രോൺ. സോ ഓക്സിഡൈസ്ഡ് ആയ ആറ്റം ഏതാണ്? സിങ്ക് ആണ്. വാട്ട് ഹാപ്പൻ ടു സിങ്ക്? സിങ്കിന്റെ മാത്രം ഇക്വേഷൻ നോക്കുകയാണെങ്കിൽ ഏർലിയർ സിങ്ക് വാസ് Zn0. Zn0 became Zn2 plus by giving away that 2 electron. 2 electron കൊടുത്തിട്ട് Zn എന്തായിട്ട് മാറി? Zn2+ ആയിട്ട് മാറി. And which is the electron atom that is reduced? Reduced പറയുമ്പോൾ ഇലക്ട്രോൺ സ്വീകരിച്ച ആറ്റം, ഗെയിൻ ചെയ്ത ആറ്റം ഏതാണ്? ഏർലിയർ കോപ്പർ 2 ഇലക്ട്രോൺ കൊടുത്തിരിക്കുകയായിരുന്നു, പക്ഷേ ഈ കോപ്പറിന് ആ 2 ഇലക്ട്രോൺ കിട്ടിയില്ലേ. സോ റെഡ്യൂസ്ഡ് ആറ്റം കോപ്പർ ആണ്. കോപ്പർ നേരത്തെ 2+ ചാർജ് ആയിരുന്നു, നൗ ഇറ്റ് ബിക്കെയിം 0 ബിക്കോസ് ഇറ്റ് റിസീവ്ഡ് ദാറ്റ് ഇലക്ട്രോൺ, ഇറ്റ് ഗെയിൻഡ് ദാറ്റ് ഇലക്ട്രോൺ. കൊടുത്ത 2 ഇലക്ട്രോൺ അതിന് കിട്ടി. സോ ദ റെഡ്യൂസ്ഡ് ആറ്റം ഈസ് Cu, and the equation of reduction is Cu2+. Earlier it was Cu2+. It received this 2 electron. ഈ 2 ഇലക്ട്രോൺ കൊടുത്തത് ആരാണ്? Here സിങ്ക് ആണ് അല്ലെ. Cu2 plus 2 electron to give Cu. Okay. അപ്പോൾ that is the oxidation equation and reduction equation. Okay, ഇങ്ങനെ ഓർത്ത് വെച്ചാൽ മതി. It will be very easy for you to understand. I'll take next topic in the next class. Thank you.